Bright Tuty. Every student matters.
Now we come to measuring speed. So as we already told you students in the previous classes, you already know how to measure distance, and we just got to learn what is the right measure of the time. Now we come to speed. Now speed is given by the formula of distance upon time, right? This is what we already got to know, that speed is telling you how much distance you are covering in how much of time. If the distance increases in less time, speed is increasing. But if the time is increasing with the same distance, you say the speed is decreasing. Now, if I know how to measure distance and how to measure time, it becomes really easy to measure the speed. So having learned how to measure the time and the distance, you can now calculate the speed of an object. Let us find the speed of a ball moving on the ground. So people, let's do an activity here. Let's say draw a straight line on the ground. So what you need to do, a straight line will be there with a chalk powder. So a straight line should be there, or a line. You can use any of these to make a straight line and stand around 1 to 2 meters away from you. Okay. Now let your friend gently roll a ball along the ground in the direction perpendicular to the line. So person, what you need to do, you need to see that the ball is moving, okay, perpendicular. So your friend here makes to move the ball towards you, right? Note the time at what moment the ball crosses the line. So let's say you have a stopwatch. You are looking at how much time the ball takes. So when the ball is starting rolling, you make the stopwatch tick. And when the ball is crossing the line, you tick it again. That is how you can measure the time for which the ball has moved, right? Also, you need to be very important to know that the time at the moment the ball crosses the line and when it comes to rest. So let's say you use the stopwatch twice. Once when the ball crosses and eventually once when it is stopping. Now, how much time does the ball take to come to rest? This is the question you need to answer. Now, people, you know that we use 1 second as the smallest unit of time. However, this is not the smallest unit. 1 second is the smallest unit for the clocks we use at our place, that is day-to-day life. But for there are clocks that can measure even less time in that. So there are special clocks which are available that can measure time intervals even smaller than a second. Now you will say, what is smaller than a second? There is microsecond, nanosecond. So things can happen in a flash of a time. That is what we define with these clocks. So some of these clocks can measure the time intervals as small as 1 millionth or 1 billionth. So as I say 1 millionth, it is 10 raised to power minus 6 second. This is 1 upon 1 million of a second. Then we also have 1 upon 1 billionth of a second, which will give me 10 raised to power minus 9 second. Now people, this is what I called as a microsecond, and this is what I called as a nanosecond. Okay, so we have devices which can measure this small of time period or interval. Now you must have heard the term microsecond and nanosecond. A microsecond is 1 upon millionth, or a nanosecond is 1 upon billionth of the seconds. Now clocks that can measure such small time intervals will not use quartz crystal. They use for scientific research, and they use even more precise vibration that can be so quick that we can measure that shorter time period. The time measuring device used in sports can measure time intervals, that is 1 upon 10th or 1 upon 100th of a second. So when you see that, even if you have measured like say that stopwatch, so 10.04 like this, the time period comes whenever there is a race. So in a race, a person can win from 1 or 2 microseconds or even 1 or 200th of a second difference. This is where the time comes very crucial. So on the other hand, times of historical events that are stated in centuries and millenniums are actually very big. They are very large. But the ages of stars and planets are even measured in billions of years. We have to imagine that what is the big range of time intervals. So when we talk about the range of time intervals, it can go from 1 billionth of a second to like light years or let's say to like billions of years. So sorry, not light years, to like billions of years for the age of the stars or the galaxy. This is what we have to understand here, that how time is very small or very big. Now we were doing an experiment where I have told you that you have to measure the ball. So when the ball crosses the line, you have to measure. So measure the distance between the point at which the ball crosses the line. So where your friend is sitting and what is the distance between the line, you can measure it using a measuring tape. Okay. So once you measure the distance, the next step is you already measured the time. The next is when the ball crosses the line and comes to rest. Now you can use a scale or measuring tape as I tell you what you need to do. Do the same experiment with different people. So let different people throw the ball at different rates. What do you mean? Somebody will push it harder, somebody will push it slower. So when you do this, different groups will repeat the activity and you need to record the measurement for each of the group. Now for each of the group, you have to calculate the speed because the distance and the time may be varying. So you may know that like to compare your speed of walking or cycling with that of your friends, which we generally do. You are walking fast, you are cycling slow. All these we do with our friends as comparison. Now what we need to do, we need to know the distance of the school from your home or from the other point so that you can exactly tell how fast or how slow a person is moving. So each one you can then measure the time taken to cover the distance and then calculate your speed. You will be very interested to know that amongst you is the fastest. Who is fastest? Who is going slower? But only when you are covering equal distance from a given point in certain time. So what time you are taking will actually define for the given distance to be who's faster or not. So speeds of some living organisms are given, right, are given in kilometer per hour. You can also calculate the speeds in meter per second.
To find the speed of different students by making them walk for fixed time intervals. Materials required: measuring tape, stopwatch. Method: call 5 friends, say A, B, C, D and E. Ask your friend A to start walking briskly in a straight line path along the football ground when you ask him to go. Tell him to stop when you ask him to stop. Now hold the stopwatch in your right hand. Blow the whistle and at the same time start the stopwatch. When the stopwatch records 20 seconds, ask him to stop and stop the stopwatch. With the help of measuring tape, measure the distance from the starting point to the end point. Now divide the distance with time, that is 20 seconds. That is, speed equals distance upon time. You find the speed of your friend A, that is 120 meters upon 20 seconds equals 6 meter per second. Repeat the same procedure with your friends B, C, D and E. Record distances covered in each case and calculate their speeds. In case of B, 100 meters upon 20 seconds equals 5 meter per second. In case of C, 125 meter upon 20 seconds equals 6.25 meter per second. In case of D, 118 meter upon 20 seconds equals 5.9 meters per second. In case of E, 136 meter upon 20 seconds equals 6.8 meter per second.
Now when we launch a rocket, the launching of the rocket of a satellite into Earth orbit attains speeds of around 8 km per second, which is huge, very, very huge, because a rocket has to take away everything away from the Earth's gravity. On the other hand, if we talk about a tortoise or a turtle, they move only at a speed of 8 centimeter per second, very slow, right? So how fast or how slow things are going, they have to be comparable units. So I cannot compare the rocket and the tortoise, because rocket takes 8 km per second and it's only take 8 centimeter per second for the turtle or the tortoise. So with the comparison is not right. You may say, ma'am, it's both 8, but the unit itself, 8 kilometer, has 1000 meter, which further has 100 centimeters. So this becomes equal to what? 8 followed by 1, 2, 3, 4, 5 centimeters. This is huge. The rocket is covering this much centimeter per second, but on the other hand, the turtle is only covering 8 centimeter per second. So you cannot have a comparison there. But once you know the speed of the object, you can definitely find the distance moved by it in the given time. Now this is true that if my speed is equal to distance upon time, can't I find or switch with the formula and find other two quantities? Let's say in a problem, I know the speed and I need to figure out the distance. My distance can be figured out by cross multiplying this with speed, and I get speed into time as my distance. So we can find out the distance covered by multiplying speed and time. On the other hand, if I want to find the time, it can again be given by switching the position of time and speed, which is given as distance upon speed. So this is what we get as with the using of one single formula, that is this speed is equals to distance upon time. I can either figure out the distance or the time as well. So we can find the time of an object covered by the distance in a given speed by this. So this is true with one formula only when we understand that speed is how much distance is covered in how much time. So if I know the speed, I can know in how much time how much distance is covered, or vice versa. Now Bojo wants to know whether there is any device that can measure the speed. The answer to this is a yes, there is. Now if you have ever ridden a vehicle or you have been traveling with your father, mother or brother or sister, you must have seen that there is a meter on the vehicle that always keeps on fluctuating the values. So the meter which is fitted on the top of a scooter or a motorcycle or in a car, these meters on the dashboard of the car or buses is what shows you the speed, and we call it the speedometer. Now the cool fact is it tells you the speed in kilometer per hour. So whatever number is coming, you can assume that you are moving with that speed at that moment. So 30 km per hour means your speed will be, you can cover 30 kilometers in 1 hour. The speedometer hence is the device used to note or measure the speed. It records what? It records the speed directly in the kilometer per hour. Now people, this is something you get to know here, that as we have defined the speedometer, that it is the device, this is how it looks like. So nowadays we have digitized these meter and you just see the number. Initially it was varying from 0 scale to 20 to 40 to 60, 80, 100, 120, 140. So you may know the average of where you are. So this is at rest because the body has no speed. If the meter is here, if the needle is here, then it means you are going at 90 km per hour. Now this table here can tell you that how much speed of different animals are there. A falcon is very, very fast in kilometer per hour. How to convert it in meter per second, students? So there is a very simple technique. For 1 kilometer is equal to 1000 meter. I have to first multiply it 1000. Then 1 hour is equal to 3600 seconds. So I have to further divide it by 3600. Whatever I get this, I get the answer here as, let me just cut it. It is 320. This will be 3. This will be 160. Then we are like left with 1600 divided by, somehow let's just cut this as well. Wait up. This is also 3. And this will be giving me 80. So 800 upon 9 meters per second is what you get as the speed of falcon in kilometer and in speed in second, meters per second. You can calculate it for everyone like cheetah, bluefish, rabbit, squirrel, domestic mouse, humans, giant turtle or snail. So you can calculate the meter per second for the fastest animals we know, and humans are there, so it is a good news, right? So there is also another meter. Now people, this is one is which is called the speedometer. But there is one more meter which can tell you the how much distance you have traveled, which is called the odometer. So in the dashboard, there is sometimes the similar board or some another board which measures the how much distance is moved by the vehicle. And that device is called what? It is called the odometer. Okay. Now, while going for a school picnic, let's say Paheli decides to note the reading of the odometer of the bus. So she says that I will note the reading for 30 minutes. So after 30 minutes, I will see where the odometer goes.